So today what we're going to talk about is our 645M-4, which is a cellular modem and Wi-Fi router. And this is now the third generation of cellular modem that ELPRO has been involved with. We had 3G cellular modems, we moved on to a 4G cellular modem, and then more recently we've moved to this particular unit here, which has a number of features that the previous 645M-1 did not have. As well, it offers a lower price as well. So we're seeing a lot of interest in this guy coming out here. But before we jump into that, I recently had a customer with an application for 6 sites on a university campus, and they wanted to network these 6 buildings together and find out what would be the most cost-effective method of doing so. And one of the things they did not really put too much consideration into was the lifetime cost of operating cellular. Now, this is only applicable when UHF is an option. There will be hundreds of thousands of applications where the distances are too great and UHF simply is not an option at all. But in this particular case, we decided to compare the two because on the university campus, all the buildings were within range of a 900 megahertz radio. So what we did is we put this spreadsheet together to kind of let them know what the difference in costs were. And we do have this. It's in an Excel format. We can send that out to you. And all we would do is just change the price of whichever radio we're looking at. And if the data costs are a little bit different, we can adjust them here. And it will calculate your lifetime cost here. Now, just to super quickly explain some of the parameters, $15 a month. This is the data cost per site per month. And then there's also sometimes the VPN cost. Depending on if you need it, the carrier will charge you for VPN access into their private network. So sometimes this VPN access is not required, other times it is. But as you can see, over a period of 10 years, the costs do add up. So not to persuade you against going with cellular, but it's important that we look at the lifetime costs when we're comparing it to a VHF, if the UHF option is applicable. So just to kind of share that knowledge with you, or feature, or something.
Yeah, I just had to get into I realized I was late for a WebEx, but
oh, I'll let you go.
Well, hey guys, it sounds to me like we've had somebody just join who has not muted his microphone. Again, if we could just, as a reminder, we are recording this session, so if I can ask you to all please mute your microphones so any coughs or sneezes are not recorded for all of eternity. So here's a couple of the major features of the 645M-4. We've got all of the major US carriers in there. We also have Rogers and TELUS for the folks up here in Canada. And we also, these modems can be used on a number of different carriers going right down through South America as well. The carriers usually just need to approve the hardware to be used on their network. Now, in terms of the speed, this is a Category 4 LTE. You're probably familiar with Cat 6 cable, Cat 5 cable, and before that there was Cat 4, Cat 3, etc. The higher the number, the higher the speed capability. So with Cat 4, we can do 150 megabits per second download, 50 megabits per second upload. The cell modem has SMS and email alarm capabilities. So there's a couple of I/O points across the bottom of the module, and we can set up text messages or email messages to be sent whenever those discretes change state. And I'm going to talk about that more in just a couple of minutes. As well, these modems provide a Wi-Fi hotspot. So what that allows you to do is you can enable the hotspot. Then you can walk up to your cell modem with your phone or with a tablet or a laptop, and you can access that wirelessly. So now you don't have to have a physical Ethernet cable plugged between the two devices. So that's very useful. For example, if you're in just in a pickup truck and you're driving up to a location, you don't have to jump out of the truck to plug into the modem to be able to have a look at it to do any diagnostics or make any programming changes. We also have RS-232 serial server. So what that allows you to do is to connect older Modbus TCP or RTU devices to the modem. Okay, I wanted to show this bit of information here. This is from the data sheet, and this shows that there are a few different versions of the cellular modems depending on where you're located. So we have 3 different models in North America. We're only going to use the US version, of course, but if you had a project that was overseas in a different country, we do have cellular modems that are suitable for those different regions. The major difference between these cell modems is the frequency bands, the LTE bands that they use. So these are different bands that are defined by cellular carriers. They are standardized, so something using a B5 band here also uses the same technology, the same B5 band in Australia, for example. Some of the key points to keep in mind are that bands 12, 13, and 14 are the 700 megahertz bands. Now, with these cellular modems, if you're shopping around, you're comparing us to some of the other manufacturers out there, check which frequency bands they have, because a lot of cellular modems do not have the latest or most recent LTE bands. So that's an important thing to check if you're comparing cell modems. Let's see, other than that, this just talks about the Wi-Fi modem inside, 802.11bgn, just like your home Wi-Fi, up to 300 megabits per second speeds, and it can be set as access point or client, or WDS, which is wireless distribution system, which effectively refers to repeaters. So just wanted to mention that. As well, we're quite lucky in the cell category here. We're quite lucky in North America. We get the Cat4 cell modem. The other regions have used the Category 1 cell modem, which is just a slower upload and download speeds. Certainly, we're not expecting these cellular modems. An industrial grade product like this is not going to be used for people surfing YouTube videos and those sorts of things, and going on Instagram and that sort of thing. So we're anticipating industrial communications, and the speeds are usually not going to be that high. Regardless, here in North America, we've got the Cadillac version. We've got that full 150 megabits per second download speed. That's dependent upon having a good, strong signal, of course. I'm sure you've all experienced it with your phone. You need to have the full 4 bars on your phone to really get a high-speed service. So, yeah, interesting to note that there are these different bands. Now, I wanted to just chat for a little bit about the text messages, and I'll just describe it in a nutshell. Is that there are some discrete inputs across the bottom of the radio, and you can wire, for example, a relay open and closed, or a voltage input into that. And every time a discrete input changes state, whether it goes high or goes low, you can have a message sent. So if we look over on the right-hand side, what we would do, this is the setup or the configuration for sending text messages out. You would just enter in a name for that text message. For example, that could be high-level alarm number 1. And then this is the text that you enter in when that alarm goes high, and this is the text you enter in that when the alarm goes low. So you could have condition high, and then you can have change this text to condition low. so that when you're looking at your phone, you would receive a text message, and it'll say alarm condition high, alarm condition low. So it can be quite powerful to be able to access that information there. We also have some other different types of SMS alarms for things like the signal quality, the received signal strength, that sort of thing. And then down below here, this is where you'd enter in the actual phone numbers that you'd like the commands to be sent to. So that's kind of an interesting capability, being able to send text messages or having the cell modem send text messages to you upon the change of an input or an output. Okay, now I'm going to just give you a little bit of background for the next couple of slides. And one of the things to think about is the public versus private IP addresses. Okay, now backing up a little bit further, when you buy the cellular modem, you'll have the hardware on hand. The next thing you'll need is a SIM card with a data plan. The SIM card is what determines what IP address you have. And those SIM cards can come with either a public or a private IP address. And here's what the differences are. Public IP addresses are available to anyone on the internet. So they can, if they knew what the IP address of the SIM card that you've installed inside of your cell modem is, they can just go ahead and type that IP address onto their browser in Internet Explorer or Firefox, and they can access your router, your cell modem. So it requires a lot more security to have in place, but there certainly would be applications for that where you would want a public IP address because you want customers to have access, or you want the general public to have access to it. A good example is let's say you've got a camera, you're watching an eagle's nest to watch the birds, the eggs hatch, and you want to share this camera with anyone on the internet. In that scenario, you would require a public IP address. There's also one or two other situations where you would require that as well, and I'll jump into those in a few more minutes. The other option, which is much more secure, is to use a private IP address. And these are now no longer available to anyone on the internet. The only way that you can access the cellular modem is if you use a VPN and you set up a VPN into the carrier's network. Now, when I say the carrier's network, I'm going to refer to both the carriers directly, like right into Verizon's network, or we deal with smaller companies that are much easier to deal with, and they have agreements with Verizon, AT&T, the T-Mobiles of the world. And specifically, we've been partnering with a company called M2M Wireless. And what M2M Wireless does is if you buy the SIM card with them, and the carrier service would be offered by Verizon or AT&T or one of the cellular companies there, but M2M Wireless has an agreement, and they set up their own private VPNs into the carrier's networks. So when I say a VPN into the carrier network, I'm referring to either if you deal directly with Verizon into their network or into M2M's network. And these are considered very, very secure because now you have to have a VPN to get into it, and VPNs are considered very secure networks. And they're what large companies use to dial into your office network when you're traveling on the road or you're at your home office. So VPNs are considered very, very secure. Generally, we recommend private IP addresses in any situation where it's possible and where it's practical. It's because of the security. So that's the reason we recommend a private IP address. So these are two options that will be available: public or private IP addresses. And in just a couple of minutes, we're going to run through some applications as to which require which type of IP address. The second point to consider is fixed versus dynamic IP addresses. Your cellular phone, for example, it uses a dynamic IP address. So that means that the IP address the carrier assigns to your phone changes every time you power cycle it, or they refresh them periodically, usually every 12 hours or something like that, or whatever time frame they prefer. So the address changes. Dynamic IP address is going to be difficult to use when you have something like a DCS system, and the DCS system is polling a bunch of remote cell modems, which let's say they have a PLC connected to them. So if your DCS is polling a bunch of remote cell phones and their IP addresses are changing, it won't work. So that's why you would have to have a fixed IP address when the addressing can only be done by IP addresses. However, if you can use a website, you can use a DNS server, which essentially converts a web address into the IP address, the changing IP address. So that's how we can use a dynamic IP address. Essentially, we use a service like a DNS service, and it converts from, it figures out whatever dynamic IP address the cell modem has at any given moment and converts that into a web page. So then you can enter just a website address, and it will do the lookup and find out what the IP address of the modem is at that time. So one interesting point to be aware of is that dynamic IP addresses can only be used when the computer has access to the internet. So, and this is because it has to use that DNS server, and that DNS server resides on the internet. So certainly something to be aware of. As a general rule of thumb, fixed IP addresses are much easier to deal with. So I think you're probably concluding, in most cases, if we can get a fixed private IP address, we're going to have the maximum level of security and flexibility. Okay, so this leads us to three very common application scenarios. And I'm just going to kind of quickly run through all three of these to give you an idea as to what we generally recommend. And let's say we have two PLCs, two programmable logic controllers. They are connected with a short Ethernet cable to a cellular modem. The cellular modem has an antenna on the connected to its antenna connector. And then the antenna, you mount, a few feet, on the top of the enclosure, or with an L mounting bracket, or that sort of thing. In this situation, what we would probably recommend is we would recommend that you use private M2M SIMs. M2M is the company we deal with to acquire the SIMs. And then we would set them up using GRE tunnels, generic routing encapsulation tunnels. And this would provide a very secure network because we're using private IP addresses. So no third parties or anybody else can get access to your network over the internet or anything of that sort. And the only way they could really get into it is if they had physical access to the electrical enclosure housing the cell modems. Now, it is possible to do this with a public IP address, but you would need security. So you would need to enable something like IPsec security. And we do have that capability on the modem, but if we can get away with a private IP, then we don't need to enable IPsec, and the setup is less complicated. Then let's talk about the second application. I have a camera that I want to share with customers, and this is just like what I outlined a few minutes ago. Say we have a camera aimed on an eagle's nest. We want to see the eggs hatch, and you want to make it open to the public. We would have to use a public IP address and with a dynamic DNS so that customers can enter in a website onto their browser to access the cell modem, which would be accessed to the camera. And what we would do for the camera, we would set up port forwarding on the cell modem to the camera, so that as soon as you type in that IP address, rather than the configuration of the cell modem popping up, the image from the camera appears. So we would have to use a public IP address with a dynamic IP and use a DNS server to route the web page to the camera, or to the cell modem. Okay, then we have another very common application. I have a service agreement and I'm installing my cellular modems on a piece of machinery, and I want to be able to access that machine from anywhere in the world where I have an internet connection. So I want to be able to access it from home, from a hotel, from or from a or the office, any place you're traveling. In that case, we would get a public IP SIM card with a dynamic IP address. And this allows internet connection to the remote modem. The remote access could be via OpenVPN. OpenVPN is just a brand name of a type of VPN software. There's a few different manufacturers of those types of software. And that allows you to get connectivity anywhere in the world there. So, yep, I think that pretty much covers that. We'll jump into how we set these guys up and all of the settings and configurations in just a couple of minutes as we move on here. Okay, now I wanted to talk about, I mentioned getting the SIM cards. I asked the folks at MTN Wireless a couple of days ago, what's a typical cost of these SIM cards? And they said it varies with the volume. So the more SIM cards you buy from them, or the more cell modems that you need to provision, the lower the cost gets. Generally, as a ballpark number, I use $15 a month as your data cost. They've got programs down to $10 a month that I've seen, and M2M has told me that they will always be competitive with other companies out there. And in fact, what I've found is sometimes we're dealing with these third-party SIM card companies. It's actually cheaper than if you were to deal directly with Verizon or AT&T. And of course, I'm sure it's just volume buying power. We recommend these smaller companies or companies that specialize in SIM cards for machine-to-machine communications, mainly because trying to deal directly with Verizon or AT&T is difficult unless you can find the right contact. If you walk into a Verizon or AT&T store and you tell them you have a cellular modem, they will probably stare at you blankly and wonder what the heck that device is. And if you tell them it's an ELPRO, they'll probably go onto their computer system and try to find out what kind of cellular phone is an ELPRO. So trying to find the experts that know all about these cell modems and can really help you provision, or if you have any technical problems or whatnot, is very difficult. This is my experience. Once you get a contact and you figure out what phone number to get a hold of, it's obviously a lot easier. But if you're just starting at the retail level and trying to work your way up, it's very challenging. So We've dealt with this fellow Sean Quinn at M2M, and one of the reasons we partnered with that is because it can be very difficult to find out if there is a technical problem. Is it the cell modem? Is it the equipment that's connected to the cell modem? Or is it the SIM card and the data plan? And Sean has actually provided technical support directly to our customers, and he knows this specific model of cell modem quite thoroughly. And it is a pleasure to have somebody who is that familiar with these types of networks on your team. So Sean, I'm pretty sure as a network engineer, I haven't really asked him exactly what his background is, but he knows the cellular modems inside out, and he's been doing this for, I think, over a decade. So yeah, just wanted to let you know this is the company that we deal with. There are others out there, but Sean in particular knows the model of hardware that we use and has offered technical support, direct to end customers to get everything set up there. So just wanted to mention that. That's why we look to a smaller partner rather than trying to deal with Verizon or AT&T. It's as I mentioned, unless you've got the right phone number and the right contact, it's impossible to drill down and find somebody at those organizations who knows cellular modems well enough. Okay, so for security on these the cell modems, and this is assuming you've got a public-facing IP address. We have IPsec and also Open VPN client and server. So a lot of cellular modems on the market are just VPN clients, which require connectivity to a third-party server. And that makes diagnostics or remote diagnostics, it makes it somewhat difficult. The 645M-4, and again, this is one of the reasons we moved to this particular model of unit, is provides server and client functionality. And that allows you to create much more secure networks. So here we go. This is just showing a typical setup here with IPsec. So what we do is on the left-hand side, we have the IPsec server, and you can see we've got a couple of parameters you need to set there inside the configuration of the cell modem. Then these go over the public cellular network, so tower to tower. And then at the remote site, we have the 645 set as an IPsec client. And this essentially now locks down these two cell modems. They will not be able to communicate with anybody else, and nobody else will be able to get into these devices here. So fairly common application. Now we also have a Modbus TCP to RTU converter on board the 645M-4. And so that allows us to connect to our serial expansion modules, the 115-S, or we can use our Ethernet expansion module, the 115E-2. And this would just be done, you wouldn't need the Modbus TCP to serial converter. This is just done over the direct by IP addressing is how this is done here. Okay, then if we run Open VPN software, now we can not only have those two 645M-4s communicate with each other, we can now log into them from anywhere in the world that we have an internet connection. So OpenVPN Just again, it's a software program that you install on your computer, and that allows you to get into the network here. So I wanted to have a quick mention about VPNs and pricing. Cellular companies and M2M and Verizon, AT&T, they charge for access, for VPN access, and it's a small monthly charge, but it is an additional charge to be aware of. So when you're buying a SIM card, you're going to have as a minimum the data charge for the actual data, how many megabits or what per month you're planning on using. And then also there is a charge for a VPN access if you need that. So for example, M2M charges $25 per month for up to 3 users. And that is VPN software that can be installed on Apple products like your iPad, your iPhone, Android products like your Samsung phones and tablets and things like that, as well as Windows-based laptops. So what they allow is they allow 3 connections for $25. And it's grouped in that fashion. So if you wanted another 3 connections, it would be another $25 a month. So just to kind of be aware, there are charges, there are costs associated with these VPNs. One thing that's neat about M2M is once you get their VPN access to it, you can log into your account. You can see how much data you've used over the past period of time. So it allows you to manage your accounts and find out, how much data you are utilizing there. Okay, now I wanted to show you this is probably one of the most common setups that we find. We have a lot of remote PLCs that are in sites where we just can't get access to, but they do have cellular coverage. And by the way, I wanted to mention about the difficulties in doing a site survey with a cellular modem, and I'm using a bit of sarcasm there. You hold your cellular phone up in the air and you see how many bars you have. And if you've got at least 2 bars, you're good to go. So again, I'm just joking about that, about it being difficult. It's the easiest thing in the world to do a site survey with a cellular modem. Now, if you look at our price list, we have 2 antenna options available for the cellular modems. And here's the rule of thumb. If you have 3 bars or more on your cell phone, you can use the smaller, less expensive antenna. If you only have 1 or 2 bars on your cell phone, you should use the larger, higher gain antenna. As well, now those antennas that we offer, they're both omnidirectional antennas, so they radiate 360 degrees. If you're in an area where you're just on the edge of having cellular coverage, there are Yagi directional antennas that you can buy for cellular applications. The one I saw was quite expensive because they do have to cover all these different frequency bands. So antennas are tuned to a specific frequency, but cellular modems, as we discussed earlier, they use all kinds of different frequency bands, ranging from 700 megahertz, and I think there's even some bands in the high 600s, going all the way up to 2 and 3 gigahertz. So the antennas, the ones I've seen, tend to be a little bit more expensive. But again, most of the time, we're dealing in areas that do have pretty solid coverage. So we don't necessarily need to use the elephant gun is what we nickname antennas that are that large. So we don't need to use a bazooka for most of the applications because it seems like cellular coverage is getting better and better all the time. And as the 700 megahertz spectrum is deployed, that it gives us even greater coverage, even longer range, better object penetration, etc. Now, one of the things you probably noticed on these cell modems is we do have multiple antenna connectors there. It is possible, if you wanted to, you could connect two cellular antennas to the modem, and that provides good multipath coverage. I would say 95 to 98% of our customers just use a single antenna because you really only need two antennas to maximize throughput. So if this were an application where you're anticipating needing a very high throughput, then we would probably recommend two antennas on the cell modem. But if this is typical PLC communications, maybe we're doing something really slow like Modbus, we definitely would not require much throughput. Even Alan Bradley's Ethernet IP protocol, which is a fair bit faster, that does not really require super high-speed communications. So you can see we have multiple antenna connectors. 99% of the time we just use a single antenna because our throughput requirements are typically not at the extreme high levels. We also have the other two antennas there are for the Wi-Fi. And again, you could put multiple antennas on the device. It does improve performance when it is moving. So if the cell modem is moving around, particularly indoors, where there's going to be a lot of reflection paths, that might be an environment where we might think about putting two antennas on. But again, that's only going to be for high-speed, high-performance applications. Let's see. So here, back to our GRE tunnels. Generic routing encapsulation is what it refers to. And the configuration is pretty straightforward for these modems. What you have to do is in the master radio, you would have to, for the setup on the left-hand side, you have to set up a GRE tunnel to each remote. So keep in mind, if you have 50 remotes, we're going to be setting up 50 GRE tunnels on the master radio. Then similarly, we have to also set up a GRE tunnel on the remote radio going back to the master. And if we had the setup on the right-hand side, where we wanted every cell modem to be able to communicate with every other cell modem, in this cell modem right here, for example, we would need to set up a GRE tunnel to this cell modem and to this cell modem. And for these guys to be able to get their data and respond back to messages coming from this modem on the right-hand side, you also have to set up a GRE tunnel in this device, pointing it back here as well, pointing it over to this guy here. So most of it's just typing in the IP addresses of the remote cell modems that you want to set up the GRE tunnels with. So for this type of setup, we'd recommend private M2M networks. You would not require a VPN, so there would be a small cost savings if you didn't need to log into these modems from anywhere on the internet. So for example, if we have physical access, we can log in quite easily and access the remote devices over the air. But we would have to have physical access. In other words, an Ethernet cable plugged into the bottom of this master radio here into our computer. If you wanted to access this master radio remotely, then you would need to set up order a VPN service from the carrier. Okay. So this just kind of chats a little bit more about GREs. The best way to think about a GRE is similar to a pipe. Nothing else can get in there. The pipe just directly connects the two devices, and no other devices are then allowed to communicate with it. So very secure. GRE tunnels are the most common application that we have, and and used in literally thousands of applications around the world. Yeah, in terms of security, the 802.11 Wi-Fi hotspot also has the highest level of security, WPA 1 and 2 encryption. Generally, that is considered unhackable with today's standards. But again, this is just a Wi-Fi hotspot. It's only shooting at a range of maybe 30-foot radius around the cell modem. So somebody has to be reasonably close to the cell modem to be trying to get into it. Okay. Now I wanted to just chat about dynamic DNS for VPN and remote access. So I've chatted a little bit about this already. I'm just going to chat a little further about this. A dynamic DNS allows the use of a changing public IP address, and again, it has to be a public IP address. Now, there are companies that provide this DNS service. They usually have a small charge associated with it. One of the providers is a website called noip.com. You can go onto that website. It takes about 10 minutes to sign up, and you just enter your basic information. And there is an annual charge. They charge about $25 a year for the service. And once that is all set up, now you can use this IP address. And every time you use that IP address, and of course it allows you to set it up as a custom one, so that obviously two websites can't have the same name. So we set up this one called 645M-4, and if you click on this one, it would then take you to the configuration. It would take you directly to the cell modem we've got set up there. So now the next thing is remote access. Sometimes you would want to access the modems to be able to check on them, see what the signal strength is, make sure they've got good connectivity. There's all kinds of diagnostics inside the device. You can look at internal temperatures and RSSI, signal to noise ratio, all that sort of stuff. You can, by being able to access it using a VPN, you can now make any changes remotely over the air. You can completely reconfigure the network if you desired so, all over the air. Okay, and yeah, just running through a couple of key features of the cell modem here. One thing I think I already mentioned is bands 12, 13, and 14. Again, this is a competitive advantage that we have. A lot of cell modems don't have all of these frequency bands. And what you'll find is you'll head out to a remote area. You'll discover that it has 700 megahertz coverage, but if your cell modem doesn't operate in that band, it'll be trying to use one of the other frequency bands. And inevitably, that will be a higher frequency, and the signal simply won't be as strong. So that's kind of a key feature. LTE band 28 is also a 700 megahertz band. That is a very common band in Asia Pacific and South America. And cell companies are adding this band mainly because they get much greater range. So it works very well in rural areas in particular, where you're not going to have a lot of users, but you will need to provide coverage here. So we don't use band 28 in the US or Canada, but just letting you know, if you get a project overseas, we do have some of the key specifications required for a good, suitable operation there. And lastly, the alarming here. I think I kind of alluded to this earlier. We've got alarming, monitoring. We've got SNMP protocol for network management systems. And what I really like is email and SMS messages to your predefined phone numbers. You just enter in your phone number and then a backup number as well. And then, of course, you type in the messages you want to have sent when any of those, discrete inputs change state. It's also possible to control the outputs, to use we've got there are 4 DIO across the bottom of the radio. I see them more commonly being used as inputs. Only in very rare circumstances would you use it as an output, but it is possible. And you can control that output as well from your cell phone by sending a text message to the modem. Okay, so just some of the other key features of the radio. We offer a 3-year warranty on the unit. Temperature range -40 to +185 degrees Fahrenheit. And it truly is an industrial rated device. Power supply, 5 to 40 volts DC. So that means we can use it off 12 volts in a vehicle. We can have solar systems powered, either 12 or 24 volt solar power systems. All kinds of different options. And dimension-wise, it's a pretty small unit. It's about the size of a deck of cards. And we have an optional DIN rail mounting connector. Or just flat panel. It's really easy. 2 screws to the back of the panel and you're done. Whoops. This one here just kind of talks about, just make sure I didn't miss a slide. Oh, yeah, okay. Sorry, just checking to make sure I haven't advanced too far ahead. This just talks about the older cellular modems that we have. ELPRO's been involved in the cellular business probably for about 10 years now. And there was a very specific reason we went with the new 645M-4. The 615 was a 3G cellular modem, so you can understand why we don't offer that anymore. The 645 was our first generation of the 4G cell modem, but the first version of that did not have a couple of key features that the newer version now has. A couple of them being that band 28 and the 700 megahertz bands in North America. So for that reason, we upgraded to the 645M-4. It also offers, it's got a Wi-Fi built in, and we found it to be it turned out to be a less expensive version that had more features on it. Okay, so I also wanted to chat about how these networks are frequently used as hybrid networks. So what we'll often find is a customer will have, for example, a bunch of our 915U2, 900 megahertz radios. They'll be gathering data from, in this example here, well sites, and they'll be monitoring this one. In fact, we did an application where they were monitoring fracking tanks. So these tanks that store the fracking liquids, and they had a series of trucks that would drive around and refill these tanks. And so in order to automate that and make it more efficient so that the trucks only filled the tanks that really required it, they monitored the levels using our 915U2s and the meshing protocol, and then got the signals to an area where they had cellular coverage, and then used the cell modems to do the backhaul over the carrier's private network to the corporate head office where they would dispatch the trucks from. And this was a great solution because most of these well sites, they did not have any cellular coverage, but they could get it to an area where they did have cellular coverage using 900 megahertz. So yeah, it's kind of interesting, but it's becoming more and more common to use multiple types of radios together here. And I just wanted to show this one here. This is a enclosure. It's a IP66 weather-tight enclosure that we have, and we can mount a cell modem inside of that enclosure to give you cellular battery-powered I/O. And over on the right-hand side, this is a battery pack right here. Lithium-ion rechargeable battery pack. So what you can do is you can just connect a small solar panel to the terminal block here. It'll recharge the battery during the daytime, and now you have cellular access in an area that does not have power. So this is kind of an interesting thing. In Australia, they use these extensively for flood warning systems. And if you've been watching the news lately and seen the recent floodings they've had in Australia, apparently it's the worst in 50 years. There's a reason why they do a lot of flood monitoring down under. Okay, that's about it for what I had planned today. I was hoping to maybe jump into one of the units live, but I ran into some technical difficulties. It's not always the easiest thing to play with the products live, so I've decided to bypass that today. But we can certainly, if there's interest, we can run another technical training session which covers the startup and configuration of one of these cellular modems there. And with that, I think I'm finished, and I think we're ready to take any questions. Matt, were there any questions there?
There were, yes, sir. Pulling them up right now. Let's see. If the WAN port is used and not the cellular portion, can I build a VPN between the landlocked 645 and the wireless cellular endpoint?
Can you set up a VPN? Yes, you should be able to do that. Yep. Just for clarity, I probably want to just have a quick look at a diagram so that we fully understand the layout of all the equipment. But as I read the question, I believe that is possible.
Okay. We do have another gentleman that will be sending both you and I their layout on another project. They'll get that over to us this afternoon.
Yep, great. Mm-hmm.
That's all the questions that we have at the moment that were I was unable to answer.
Okay. Great. Okay. Well, excellent. Well, thank you, guys. Appreciate you logging on today and taking an hour out of your day to hear about our products and what we can do and what kind of solutions we offer. And we will have another session in 2 weeks' time. I believe that one is on our 415U2, our 450 megahertz licensed radio. And in that case, I will be running through the software, showing you how that unit is configured and how to set that unit up for performance, et cetera, et cetera.
Perfect. And for those who have team members that weren't able to join the call, we will have the recording of this posted to our YouTube channel later this afternoon, latest tomorrow morning.
And
Thank you.
And Brian, thank you so much for a great presentation.
Okay, thanks, guys.
Thank you. Have a great day.